Hello, today's topic is chemical reactions. Uh, to study chemical reaction, we will be having four video lectures. In this unit, we have four modules. One after another, I will be uploading. If you like them or you do not like them, please give your reactions, share if you like it, and you can always reach me back to ask your doubts or to suggest some improvement. Okay, let's start. So, when we are talking about chemical reactions, first of all, what's that? Reactants giving rise to products. As simple as that. What's reactant? It means some substance getting transformed into some other substance or substances. So, those which are interacting, those substances which interact with each other or they give rise to some other substance that because of some reaction taking place, that's called reaction. That process of converting one substance into other, that is called reaction. And the substances which interact together to give rise to new substances, those are called reactants, and the new substances will be called products. So it's nicely depicted in this video. Then how do we know that chemical reaction has taken place? What are the indicators? First of all, gas evolution. Let me give you some very basic example. When you open your soda bottle or your cold drinks, carbonated cold drink bottle, then you find some bubbles are coming up. That means some gas is formed and coming up. How it is formed? No reaction is taking place. We did not mix anything. Yes, reaction is taking place. Actually, in the bottle, initially carbonic acid is there. And because when we are opening the bottle, pressure is lowered. When pressure is lowered, what happens? Carbonic acid gives rise to carbon dioxide and water. This carbon dioxide comes out as gas. Reaction taking place. Color change. Let me give some example from our life. If you know cooking or you have seen your mother cooking, you will find that while cooking, the ingredients change color because chemical reaction is taking place. And obviously, the taste, texture, everything gets changed because new substances are getting formed, right? But when you add salt to water or sugar to water, taste changes, but it's not chemical reaction because salt remains salty, sugar remains sweet, right? Only the water's taste get changed. Uh, but it's not chemical reaction, it's just combination of two things. It's a mixture, homogeneous mixture. We have discussed this in our matter section. Okay. Next indication is formation of precipitate. Uh, have you seen cloud formation in home? Actually, when you, or let us say cottage cheese formation, uh, paneer, when you add lime or lime juice or vinegar, acetic acid to boiling milk, you will find that milk protein, casein, is coming out. It's getting separated from watery part of the milk. So that is precipitation and its reaction. Yes, reaction taking place. The protein is getting precipitated out. Then heat and light may be evolved if reaction is taking place. Like when firecrackers are cracking, then bursting, then you will find heat and light both are coming out. That's because of chemical reaction, right? Then how do we write chemical reactions? Is it okay if we write hydrogen plus oxygen giving rise to water this way? Won't it be too difficult when you have to write bigger reactions involving large number of substances, which gives rise to large number of products, and you need to balance them? What's balancing? We will come to know soon. Yes, it will be really tedious and lot of space will be consumed, time taking. If we have learned symbols and molecular formula. If we use those to write chemical reaction, it will be easier, right? You can see the example here, hydrogen plus oxygen giving rise to water that becomes so small when we write two hydrogen molecule plus one oxygen molecule giving rise to two water molecule. Why these two are there, we will come to know soon. And it's not molecule, actually two moles of hydrogen reacting with 1 mole of oxygen giving rise to 2 moles of water. We will discuss all these things little later, but definitely it's easier way and correct way to write chemical reaction. It's chemical equations now, right? Then equations are called skeletal equation when they are not balanced. You see here iron plus water giving rise to iron oxide or ferric oxide plus hydrogen. It's not balanced. Why? One iron atom is on the left hand side and as product we are getting three iron atoms. Are those iron atoms created? Definitely not. Atoms can neither be created nor can be destroyed. Similarly, one oxygen atom giving rise to four oxygen atoms, not possible, right? So why do we need to balance? To maintain, to follow law of conservation of mass, which is naturally followed. If we do not write it properly, then we are making mistake and that mistake will lead us to wrong result, right? Atoms are conserved. We have learned this from Dalton's atomic theory from that time, right? So how to balance? We need to follow some rules. The basic rule is first you need to balance metal atoms, then non-metals, then go for hydrogen and lastly oxygen. And while balancing, we cannot change the subscripts. We need to use coefficients only. Change the coefficients or use coefficients. For example, I went back to this slide. Here, if I write instead of H2O to balance it, to balance the oxygen atom, if I write H4O8 and on right hand side H4, then, sorry, not H4O8, rather H8O4. And then oxygen is balanced. And on right hand side also we can write H8. Can we? No. H8O4, there is no substance like that. If we are changing the subscript, the substance is getting changed. So we can write instead. Okay, let us see what we can write. It's there in the next slide. So H2 plus Cl2 plus HCl. If we are writing H2 plus Cl2 plus HCl, it's not balanced. This coefficient 2 is balancing the equation. This 2 is coefficient. So let us go for some balancing examples. Zn plus HCl, ZnCl2 plus H2. So here 2 is written in front of HCl. This is coefficient and now it is balanced. And we are coming back to that example, Fe plus H2O giving rise to Fe3O4 plus H2. Now if we write 3 in front of Fe, 4 in front of H2O and 4 in front of H2, then it is balanced. See, all the atoms on count of atoms on left hand side of the equation and right hand side of the equation is same. That means the equation is balanced, mass is conserved, atom conserved, right? Now next is what are the different types of reactions? Let's see. Combination reaction. The name suggests two things combined together to form one thing, or maybe more than two things combined together to form more than one thing, but they combine. So next is decomposition. Decomposition means definitely getting separated. So one or more thing will get separated into more number of things, right? Then displacement. One of the element will get displaced by other. It is shown here with colored balls. Then double displacement. One of the element will get displaced from each group if two different substances are there. And it is shown. We will go to each of them now. So combination reaction, a reaction in which two or more substances combine to form a single product. So general form will be A plus B giving rise to AB. Examples are given here. Magnesium, 2 moles of magnesium plus 1 mole of oxygen giving rise to 2 moles of magnesium oxide. 1 mole of calcium oxide plus 1 mole of water giving you 1 mole of calcium hydroxide. So all these are combination reactions. Decomposition reaction, a reaction in which one compound breaks down into two or more simpler substances. General form AB giving rise to A plus B. Examples, if you see, mostly like A plus B. Calcium carbonate giving rise to calcium oxide plus carbon dioxide. Water giving rise to hydrogen and oxygen. So first one is thermal decomposition, second one is electrolytic, because first one needs heat, second one needs current for this decomposition reaction. Third one is photochemical because it needs light for this chemical reaction. So 2 moles of silver chloride giving rise to 2 moles of silver and 1 mole of chlorine gas. Then displacement reaction, a reaction in which a more reactive element displaces a less reactive element from its compound. So general form A plus BC giving rise to AC plus B. C is replaced by um, sorry, A is replacing B, not C is replaced by B. I was about to tell that. That was um my mistake. So A is replacing B, right? So let us see the examples. Zinc plus copper sulfate giving you zinc sulfate plus copper. So here copper is replaced by zinc. Similarly, iron plus copper sulfate giving rise to iron sulfate plus copper. Here copper is replaced by iron. Then double displacement reaction, a reaction in which two compounds exchange ions to form two new compounds. General form AB plus CD giving rise to AD plus CB. Here B is replacing D and D is replacing B, right? So sodium sulfate plus barium chloride is giving rise to barium sulfate plus sodium chloride and its precipitation reaction. That's why that down arrow is given. Then HCl plus NaOH giving rise to NaCl plus H2O. Then redox reaction. What is meant by this? Redox is formed by two different words, reduction and oxidation. Oxidation means loss of electron or gain of oxygen. Reduction is gain of electrons or loss of oxygen. And this oxidation reduction, they both occur simultaneously in the same reaction. That's why we call it redox reaction. Example, you can see zinc plus copper sulfate giving rise to zinc sulfate plus copper. So zinc is oxidized and copper is reduced. It's not CuO, CuSO4. I'm so sorry for this mistake. I'm so sorry. It should be CuSO4. Let me write this, correct it here itself. So this one should be CuSO4. That is getting reduced. Okay. Okay. So let's go to the next one. Next slide. Okay. Let me remove this writing. I'm so sorry about my handwriting as well. I should have been sorry when I was a kid, but I did not rectify this mistake, and for that my teachers suffered when they corrected my papers, and now my students are suffering. I'm so sorry. Anyways, some practice question. Balance this equation. So let's see how it is balanced. Aluminium plus oxygen giving rise to aluminium oxide, but one aluminium becoming two aluminiums and two oxygen atoms becoming three oxygen atoms. So I need to balance, or better to say, we need to balance. Okay, let us see if it is getting balanced. No, this is not balanced. Yeah, not balanced. Now, yes, it's balanced. Yeah, good. Then, what are the common errors we make? While balancing, if you change subscript, that's really bad. Then, skipping balancing, we should not do it. Law of conservation of mass is to be followed when we are writing that, right? So, these are lesson check questions. Define displacement reaction. Why does zinc replace copper from copper sulfate solution? What is double displacement reaction? Identify this reaction. HCl plus NOH giving rise to NaCl plus H2O. Which type of reaction it is? It was so easy. Define oxidation and reduction. Identify oxidized and reduced species in this. Yes, this was there actually. Copy paste mistake. Yes, while making the slides, I copy pasted and that got caught. Now, don't do this. Okay. That was not common mistake in the list of common mistake, but I have proven that it's also a common mistake while doing anything on computer. Okay. Reaction identification practice. Identify the type of reactions. For all this, it's your task. I won't answer them. Define combination reaction. Identify this reaction. Yeah, obviously combination reaction. What is decomposition reaction and classify this? Yeah, again, decomposition reaction. So, I hope I could make it bit simple. Chemistry can be made simple. I don't know if I am successful or not. Your reactions will tell me whether I am successful or I need to improve myself. Okay? Thank you.